Hello and welcome back. Go ahead and do your warm-up on your note sheet. You will be turning in your notes when you have completed this video. Go ahead and pause the video to work on your warm-ups. I'm going to move on with the notes. So today we're doing 1.4 notes. It's the power of a product and the power of a quotient. You saw a little bit of this yesterday, but we're going to deal with things when they're not the same exact base. So, day one, we're just going to do power of a product. So we're going to use the order of operations to solve like we did yesterday, so that's PEMDAS. Remember, you do parentheses, exponent, multiplication and division together, addition and subtraction together. Okay. So my first example is going to be to evaluate, which means I want some number answer, not in exponent form necessarily. So I have 4 times 5 cubed. So what I'm going to do is what I did yesterday is multiply those inside. So that's going to give me 20 cubed. Okay, because 4 times 5 gives me 20 and the cube just comes along for the ride. And now I'm going to do 20 cubed is 20 times 20 times 20. And if I actually multiply those three numbers out, I'm going to get 8,000. Okay. Another way to think of it, which is a little more complicated, just takes longer, but if this works for you, that's fine. I'm going to rewrite my problem, 4 times 5 cubed. You can think of this as being 4 times 5 times 4 times 5 times 4 times 5. If I rewrite that, that's 4 times 4 times 4, because that's my 3 4s here. And then I can write my 3 5s. I just write them next to each other just because it's neat. If I want to, I could rewrite that in exponential form first. So that would be 4 cubed times 5 cubed. And then I can get 4 cubed is equal to 64 times 5 cubed, which is 125. And now when I multiply those two numbers together, we get 8,000. This is typically the way we do it when we have actual numbers. This way is more for when we have variables. Okay. But either way will work. Either way will get you the correct answer. As you can see, we get the same answer no matter which way I go. If you need to use a calculator for 64 times 125 or 20 times 20 times 20, that is okay. But you should still show some of these steps for when you're trying to get your answer. So since we talked about variables, let's do an example with it. So let's look at h times k to the 4th. So notice how, unlike yesterday, these do not have the same base. Okay, there's an h and a k. So I actually have to write this out. This is h times k times h times k times h times k times h times k. Okay. So I have 1, 2, 3, 4 sets. So I'm going to look at all my h's here. There's 4 of them, right? So that's really h times h times h times h. And then if I look at my k's here, I have 4 of these k's, right? So if I like to rewrite it longhand, k times k times k times k. Now if I write this in exponential notation, which is how I should always end these types of answers, is h to the 4th times k to the 4th, which I can rewrite without the actual multiplication symbol because we can assume there's an invisible 1 there. Okay. So this is how you should do it again with variables, okay? You should end with some sort of exponential notation here, okay? Not in this form. Now some of you can skip from this step right to this bottom step, and that's fine, but I want to see some sort of work in between there. Okay. If you notice, if you want to get really interested in it, this 4, all it really did was distribute to the h, and then it distributed to the k. But you will learn that later in some of your other math classes. So that's kind of the shortcut for getting from here to here. Okay. Let's do just a little note here for you guys. No, you can't see that at all. So note, to find the product, find the product. Product means multiplication, remember, of 2 algebraic expressions. Oops, sorry, expressions didn't really fit on the page there. This is expressions there. with the same base, I'm sorry, with the same exponent. Goodness, I apologize. You can multiply their bases. So that theorem, this general, remember, very mathy term, is a to the m times b to the m is equal to a times b to the m. And again, this is just the very mathy term of it. We're going to do some examples with it in a second. But to find the product of two algebraic expressions with the same exponent, you can multiply their bases. Last week we learned about if they have the same base, you can add their exponents, okay? So this is kind of like the backwards way of thinking of this one. Okay. Let's go ahead and pause it if you need to continue writing that explanation down. I'm going to flip my page over and do my other set of notes here. So if we look at some examples using that theorem. So I have 3 to the 4th times 7 to the 4th, and I want to simplify this expression, so that would have been my directions here, simplify. So again, I have, both of these have an exponent of 4. So based on my theorem that I just stated, I can multiply their bases. So I have 3 times 7 to the 4th. And I know that 3 times 7 is 21 to the 4th. So these are just equivalent expressions. This is just another way of combining terms. Before we learned when they have the same base, I can add their exponents. But when the exponents are the same, I can multiply their bases. Okay, so that's how that works. Another example. So I'll give you a second if you want to pause it here to try the problem. I'm going to zoom in just a little bit for you guys. Again, here, because I have the same exponent, both of these are to the 5th power, I can multiply their insides, or multiply their bases. Okay, so I have negative 1/3 times negative 2/5. Now this is the real test to see if you guys remember multiplying fractions. Remember, when you multiply fractions, you just multiply straight across. So I have negative 1 times negative 2, which gives me a positive 2. 3 times 5 gives me 15. And I keep that to the 5th power. Okay, we're going to leave it in exponential notation right now. But eventually, you'll learn in your later math classes how to get this as a regular number, not just an exponential notation. Okay, here's another exponent, or an example, not exponent, with a decimal in it, but it still applies. This would be one if you wanted to use a calculator, you could. Again, I have the same exponent here. They're both to the power of 3. So I can multiply their insides. So I have negative 2.4 times 0.5 to the 3rd. And if I multiply them on their insides, I have negative 1.2 cubed. And again, I'm going to leave this as an exponent notation. Okay. Just a couple other brief ones for your help here. 6 cubed times 7 cubed. Again, because I have the same exponent, I can multiply their insides. So 6 times 7 cubed, which is 42 cubed. I can do the same thing with variables. So I have a to the 4th times b to the 4th. Again, because I have the same exponent here, I can multiply their bases. So I'm going to have ab to the 4th. And there's nothing I can do since a times b is just a times b. I can't combine that any farther. Okay. If you want to get really fancy with your variables, okay, so I have 2r as one of my variables and 7s as the other base there. But they still have the same exponent, so I can multiply the bases. So I have 2r times 7s to the 5th. Now on the inside, I can combine this 2 and the 7, because I know that 2 times 7 is 14. So I would have 14. The r and s just come along for the ride, and the 5 just comes along. Okay. So this is how I combine multiple things together. This is the product and power property together. Notice how the inside was our product things, and then we have power over here. Okay. So this is how we're combining these different exponential properties. Okay. Go ahead, this will be like your exit slip for the day to finish off the notes, where I'm not going to give you the answer. I want to see how you do. So try, if I give you something such as 5 cubed times 6 cubed. What answer is that going to give me? Okay. Once you're done with that, please submit your notes on Google under this same note-taking video. Thank you. Have a great day.